Hi guys, welcome to Learn Electronics Repair. I have two PCBs here. These are from an air conditioning unit, what's called a split unit. So this has the compressor unit outdoors. That's like the big sort of grey box with a large fan in that you often see on the outside of the building. And then you have like the head units, if you like, whatever they call them. I'm not an aircon expert. They are indoors. So the problem with this one is that on the indoor unit you have an error code F4, F for Foxtrot 4. The reason I have these is I was speaking not long ago to a guy who repairs aircons here and also fits them. And that was actually about another air conditioner PCB I have here, which I haven't looked at just yet because the guy's back in the UK at the moment. But basically, during the conversation, he says he doesn't actually repair these things, he replaces them. So he said, I might have some work for you, and then lo and behold, this turned up. So the guy, he's been out to this, he had a look, he says the fault is in the PCB or the controller board, and basically asked me if the guys could call me, so they called me. I went out, and this time I actually went out to the unit. I didn't see the error code because he's told me what the error code is anyway. That's fine. I did check, and I know there's power getting into this, mains power getting onto it. But this board, the little 7-segment LED display, doesn't light up, doesn't seem to do anything. Nothing's really happening on this unit. This code error F4, I had to look it up. This is, I suppose it will also vary on the type of aircon, but a lot of these use a similar code. And this error basically is like a communication error between the indoor unit and the outdoor unit. And it suggests the problem is an EEPROM on here. I found a video on YouTube about this. In fact, I'll just show you. So this is one of the videos I found, and we can see F4. Okay. So it shows us where the EEPROM is on different boards. Okay.
The main chip of indoor or outdoor PCB cannot receive the feedback from EEPROM chip.
So it then tells us basically how to fix it, which is switch it off and switch it back on again, basically. Okay. And then the same with the remote control.
If it is still displaying
Okay.
E0 error code, replace the indoor main PCB.
Okay, replace the indoor PCB.
If it is still displaying F4 error code, replace the outdoor main PCB.
And we have the F4 code, okay? So it really doesn't tell you very much, does it? It just says like
If it is still displaying
E0 code indoor,
replace the outdoor
F4 error code outdoor. So yeah, it's like your car don't go, so replace the engine, yeah? Huh, there we go. And then you replace the engine and find the fault was that the battery was flat. Okay, I'm not impressed. There is another video about this error.
the EEPROM memory.
Okay, so again, we have in this video, it's usually the EEPROM.
Try to resolve this issue
Okay.
as follows.
Again, they advise the same thing, switch it off and switch it back on again. I think somebody copied somebody else's video here. Okay.
3. Focus your examination on the external electronic module.
Okay.
Conduct a visual inspection to check for any damage.
Yeah.
Locate the card controller and the
Yeah.
nearest integrated circuit, which has 8 terminals, 4 on each side.
Okay.
5. There is a possibility that the problem is caused by an electrical resistance near the EEPROM memory.
I think he means a resistor.
Make a detailed measurement, first of the resistances near the memory.
Okay.
then of all the resistances.
I'm guessing that's a pull-off resistor or
If any resistance does not
in line
come
with the
down
data.
close to what it should be, replace it carefully.
Okay.
7. Once the electrical resistance is replaced, Try to start the equipment again to see if the F4
Replace your
error
electrical
disappears.
resistance, yeah.
8. If the F4 error persists, the problem is likely directly related to the EEPROM.
Okay.
In this case, the memory must be replaced with another one that has the appropriate programming or that
Well, shouldn't we reprogram it? I don't know. I don't know how we get the firmware. Could be interesting, this repair.
belongs to another electronic board of the same model that we are repairing. 9.
Oh,
EEPROM
so I think they're saying you need to have a good EEPROM file. Well, let's see. I mean, if we end up down this route, yeah.
is a type of non-volatile memory that allows electronic data to be written,
Okay.
erased, and rewritten. It is used to store information in electronic devices, such as settings or data that must be retained even when the power is turned off.
So basically, this one has given us a bit more information. They saying check the resistors around the EEPROM and replace it if they all read okay.
Programming the new memory with this data ensures that the air conditioning operates according to the original manufacturer's specifications.
Okay. So that gives us a little bit more information. I saw another video, I'm just struggling to find it at the moment, which actually gave about 10 other possible reasons for this fault, not just this EEPROM. So let's have a look at ours. Let's see if we can get anywhere with this, okay? So to be fair, that second video did give us some information on that, some idea. So that's probably where we should start. The aircon itself, by the way, is this one. So Giatsu model 3D DC axial. That seems to be the one we have. This model number. Okay, so that's the one. It looks like this. Okay, so this is the actual unit. Hopefully some of you guys know this one. Yeah. But let's make some preliminary investigations. Let's see what we can figure out, because I'm not totally sure even the power supply is working if this is not lit up, but it could be. This EEPROM error, I guess. Because I went out myself and disconnected all this, taking lots of photos of where the wires go, by the way, I have this, so this was on the inside of the top cover. I can see this is the little board with the LED display, the 7 segment. So we can see power comes in here. I had mains power here. I did test that. Power then goes out here. I didn't actually check this. This goes onto the larger PCB. And this is where this EEPROM is, from what I've seen on those videos. We can see the connection to the compressor and various other things. So at least I do know what connects where on this, and that may be of help. So with this one, at least we know how some of it connects up. We have some chance maybe. I'll check first to see that the power is getting from here through here to this one. If that is the case, then I'll have a look at this. I think this has the actual power supply in, so we can see the large capacitors down here. I'm expecting this has some sort of switch mode power supply on here. This may also have, or it may get its power back in through here actually, that powers up the display. Okay, we have a plan at least. Having said that, this doesn't show any power getting back to here, but this diagram is really to show how you connect the various external parts of the aircon, the system, so it probably wouldn't show if the low voltage power is coming from here back onto here anyway. Let's start with this one, because this is where the power comes in. So we'll start at the beginning, but I won't spend too much time. We'll head towards that EEPROM if we have to, yeah. Okay, so we have, what is that thing? Is that a relay? We have a fuse. We can see where it says fuse here. We have a NTC. We have a bridge rectifier, quite a small one actually there. This may well be a power supply that powers this. What's this IC? Is this a voltage regulator? Yeah, 7805. So we can say that this unit actually contains a power supply which I assume will take the board out, powers this. So we should be able to test this. If we apply mains power to it, we know where the power comes in. We can measure for voltage here, so I think we can probably just test this on its own. I mean, it may need some signal from here. It may well be that this is an output going to the other board, but I think the other board has its own power supply. So this we can check, okay? The battery is flat in my Fluke, so this is the modified Mr. Bleep. Yeah, this is the cheap multimeter I built the Mr. Bleep function into. You can hear it quite clearly there, and it gives a blip on the diodes as well, different for Schottky and normal silicon diodes. Actually, it's better in its way. It's also faster, actually. I'm sure I can link the video where I built this thing. Okay, so power comes in. Let's just see if this goes. Yeah, that comes in and goes directly out there. I think this is the neutral. Yeah. Yeah, so the mains power just goes straight through here, okay? And that's where the terminals go down to the main board. So this thing is clearly a power supply. In fact, it shows us the high voltage area and the low voltage area. Nothing was going bang on this, so I think what we'll do is we'll attach the power. We could attach it here or here, to be quite honest, and let's see if we have any output from this power supply. This could be the first point of failure, so let's have a look. Okay, so I've attached the power as per the diagram, so live and neutral. I've attached the current limiting light bulb over there, but this probably won't do very much. I'll just switch the limiter on. It wasn't doing anything drastic on site, so it should be okay. Doesn't light up. Oh, it lights up dimly. Oh, it's actually working. Switch that out. This lights up. You know, I could not see this on site. Yeah, I'll switch it off and on again. It's not very bright. I wonder if it's just that it's so dim that you can't see it outdoors. Which, being an outdoor unit, yeah, 0, 0, E0. Being an outdoor unit, that seems a bit silly if you couldn't see it, but I could not see that lit up. And yes, I know I had mains here because I measured it, I checked that on site. So maybe that's a red herring. Let's have a look at the other PCB, see if we can see anything obvious in the direction of that one. But with this one, well, the mains comes through to the output terminals and this powers up and runs. So I'm confident enough to say this thing is actually okay. Here is the other PCB. So there's lots of connectors here. I took photographs of where this lot goes to. I'm guessing 2 of these are the power coming in off that other board. If I looked at the photographs, I can probably work it out if I need to. Okay. So let's see if we can get to this main board. It looks like it's in this plastic tray thing here. I can see the rear of it quite clearly. I can see a fuse, so we can check the fuse first thing. Yeah, and the fuse reads okay. We can get rid of that light bulb because we don't need it right now. Right. I'm just going to check to be sure there's no power in these very large capacitors. I mean, this has been off since yesterday morning when I picked this up, but you know, this is the best way to find out using the multimeter, not your fingers. That reads okay, there's no voltage there. And this one, okay, so that's safe, right. How is this mounted into this case? There's a big heatsink here which attaches to the PCB like a big metal frame. Let me see if I can figure out how to get this apart a little bit more. Yeah, this is not so difficult. So there were 4 pins in here, okay, quite long ones, which bolt the devices to the heatsink, and we take those out, and this now all comes loose. I thought it must be fairly easy because the video said change the motherboard, the main board. So this should come out without too much trouble. Okay, I have the PCB out. I had to disconnect these two from the fuse, which was on the metal casing. We can see now we have two look like bridge rectifiers here. We have some rather fancy looking IC here. Seems to be a single device. Okay. We have 1, 2, 3 more fuses on here. So we'll start with the fuses. That one's okay. That one's okay. That one's okay. Just looking for power devices now. So there's a few diodes on the back. One mounted to the heatsink here. The 2 bridge rectifiers. I really don't know how to test this thing. It's a rather strange device. Don't really know what that is. It's probably marked on the other side, so I can't see. This looks like another little switch mode power supply. So the controller here, that must generate a voltage to supply this lot, I'm pretty sure. Okay. The fuse is intact, so that's a good sign. Okay, so a couple quick checks. We'll just look for the main semiconductor devices, see if they read okay. I don't believe there's any shorts on this because it's not blowing any fuses. So, yeah, so reads okay, reads okay. Look for shorts, nothing there, short all the way. This is a switch mode power supply again, quite obvious, a low powered one. So the reason it's quite obvious, you see the missing pin there. This is the high voltage pin, this is the transformer. These TOP whatever chips, these are switch mode controllers basically, at least the ones I've seen. Looks like a voltage regulator or something. Yeah, another 7805 on the output. So this is another 5-volt supply, and this will supply some of the chips in this area. So we could power this board up again, like we did with the other one, and just figure out if we have supply here. That's another good step. If we do have supply into this area, 5 volts, then we can look for this EEPROM. Let's just check this. This is some sort of power device. We can see it down there. Can I get it to focus? This is probably 2NC06. This is a MOSFET, so we can probably not say for 100% sure, but that is the gate to the source probably. Drain source. Let's go the other way around. We should see a parasitic diode. No, we don't actually. That reads a little bit strange. Maybe I should take this one out and just check that. It's marked. Oh, you know, this thing is a gate collector emitter. This is a not LGBT. What do they call them? Something like that. IGBT. Okay. Insulated gate bipolar transistor. I think I need to make a video about these so we can talk about them. So I'm not surprised now we have some rather unusual readings around there. We have a few relays on here, which of course which could be faulty. A couple of them here at least. BA290, probably quad op amp. Those BA things, I haven't looked it up. A few of the chips I don't particularly recognise. 4560, that's a dual op amp. It's a dual op amp. Wouldn't be surprised if it's another one. Yeah, this one BA2902 again, 2901, 2902. So these will need some sort of supply voltage as well. Normally these have like a split supply rail, 456. So let's look that one up and let's have a look at this one and just figure out what sort of supply voltage we might expect, because it's possible that there's more than one output on here. Yeah, I see 3 diodes directly by here, so I think we can say there are 3. We're going to have a supply feeding into this, the regulator. This is the input pin. Expect that to come from one of these diodes. Yeah, that one. So that is feeding that 5 volts, and then there'll be a plus and minus supply here, I would imagine. That reads okay. That reads okay. That reads okay. Yeah, so they all come from the same transformer, so I think we can say if the 5 volts is there, these will be there as well, but we can measure them on the op amps. So on second thoughts, I don't think we need to look up the data sheet of these right now. Okay, where's this EEPROM? So here's the processor. There's another BA whatever. Don't see what looks like an EEPROM around here anywhere. Okay. Nothing obvious. 2903. Well, these two I can definitely eliminate because I know that chip. I know what they are. 2903. I don't know. This is very close to here. Who knows? I think probably not. Probably not the EEPROM I mean by that. Other side of the board. Ah, that looks like it could be an EEPROM. Let me get the microscope. It's a bit hard to read that. You are covered in gunk. Let's try and just clean that off with a bit of ISO. Well, it looks like a sort of EEPROM number. It's a 93C66WP. So it's not your normal 24 or 25C or Q or the various ones you find on things like motherboards. Certainly I don't have one of those. Let's look for a data sheet. And I have a data sheet. So 93LC, 93C, ABC. Okay, mine says 66WP. So I don't exactly say an A or a B or a C, but it shows us 2 pinouts for this package on the SOIC. So small outline IC SOIC, that's the package. Could be this pinout, could be this pinout. I think we could figure that out by tracing from pin 8 VCC or just measuring on there, see if that's where the power is, rather than here where we can see it's on pin 2. Okay. It has a chip select pin, which could be on 3, could be on 1. That's kind of like the pin out you'd probably find on the sort of EEPROMs we're more used to. Okay, so it would be possible, I think, to see whether or not the processor is trying to access the EEPROM. We should see that line. Well, CS doesn't have a line over, so it suggests this is active high, but I wouldn't be surprised if that's just wrong and it's active low. Okay. Who knows, because I don't know this chip. Maybe you know. So that's the EEPROM. Right, we need a plan. We need a plan. Well, we can solve the mystery of the pinout easily enough. So here is our voltage regulator. This is the output, the 5 volts. So that go to, yeah, pin 8, which is there, not pin 2, okay? So that is the power, and this would be the chip select on here, okay? So at least we know the pinout. So I suggest we power this up. We know where the power comes in, so that's not too difficult to do. We check the 5 volt supply rail, I'm not sure what the other two will be, but there'll be a plus and minus, symmetrical and ground. We know where ground is, and we know the pinouts for these op amps. So, at least I know the pinout for these op amps because they're common ones. So this should be a negative supply. This should be a positive supply of equal voltage, basically. Ground, we can say, let me just find the regulator again, and I will say, yeah, it's up there. So, assuming it's not an isolated ground from this ground, but I don't really see why it particularly would be. I can't actually get onto the chip itself. Okay, it's plastic on the back, there's no metal tab. It's too low to the ground to actually get onto it. But from the rear I can probably figure it out, so center pin will be ground, goes to some capacitors, goes here. So C109, C69, let's see if we can just find those. Well, there's C109, this is the negative end. Does that go to the negative end of this one? No, does it go to the positive end of this one because it might be reverse polarities on here? Let's have a look. So, looks like it goes under there. Yeah, so that point, and that goes to ground on here. I just can't easily get under there to it. It's also here by the looks of it as well. You can hear it, can't you? Without seeing the meter. Okay, so we know ground's here. So if we measure from here, we should be able to see a plus and minus supply there, okay? So that's not too difficult to measure. If I can see a positive and negative supply, and I can see the 5-volt supply, then I think we have to go down the route of it is the EEPROM. That's apparently a common failure on these. How easy it is to find an EEPROM for this Giatsu aircon, I don't know, and I think I might have to ask some of you lot. Okay, we'll find a forum. You know, guys, I'm an electronics kind of like general purpose guy. I'm not specifically trained or have the specific knowledge on this type of thing when it comes to firmware. Okay, so let's figure out how we power this up. Shouldn't be too difficult because we know where the power comes in. And then let's see if the power supplies are actually all there. So this is where the power comes in. We can see the black and the white wire. This is a big double inductor basically filtering. So power in there, that's one of them. Power into the other one, I think it's this white one. Yes, that's where the power comes in. We can connect our mains here, no problem. Then this one goes through a inductor, same with this one. This then goes through a resistor here actually, which is actually 35 ohms. That could be a thermistor, it's marked as R1. It's this thing here, so it's a bit hard to say what that actually is. Okay, but that's where it goes through there. Then you can see an orange wire which goes over towards these bridge rectifiers, which is here marked orange. So this goes up to the bridge rectifier on one of the AC inputs. So let's go back to continuity again. Yeah, that goes there. Doesn't go to this one, I'm not sure where that one's connected actually. It says orange here. Okay. Well, it certainly goes to there and there. It does go to both of them, okay? You can hear it now, bleeping. And it's reading, okay? So that's one of the AC inputs via this resistor. Okay? And the other AC input you'll see doesn't go to the bridge rectifier, not directly anyway. Yeah, there's nothing there. That goes here, and then it goes to where it says here, reactor white, okay? Reactor white. So something connects to there. and then it must come back on another wire. Let's have a look. So this one is reactor white, goes up here to this thing. Okay, and that comes back down here on red reactor, which is that one. Okay, and red reactor, we can see it goes under the bridge rectifiers. So red reactor is the other input on the bridge rectifiers. Okay, so this reactor, I had to Google this because I'm not that familiar with aircons, but basically the reactor is like an inductor that filters out mains noise, if you like, or noise from the motors that this thing is driving. I don't have one. I probably should ask the aircon guy I know, Lloyd, if he can just let me have an old reactor. He'll probably have one. So I need to effectively bypass this to power this up. Now, I could just short these together so the reactor or choke isn't in circuit, because I have nothing else powered up from this. It shouldn't be a problem. But you see, lying on my desk, I have this. So this is a choke from an old ATX power supply that has passive PFC. I never thought I'd ever have much use for one of these, but now I do. So I can connect this as the reactor. That'll effectively do what the reactor does, and bear in mind I have no load attached to this, no motors or anything. So we can use this in place of our reactor on here. The other thing I want to make sure of is that none of these wires touch anything else, because I don't know where there might be power on any of them. We can see the input wire, so we know where the power comes in on this black one and on the white one. So I'm going to put a bit of insulation tape around these various connectors so nothing accidentally shorts together, and then I'm going to power this up. Okay, so I've connected the power onto this. I'll just put a little bit of insulation tape around here as well, just to keep that in there so it doesn't touch anything as well. Okay, so we can just check this from the power cord. Yes, that's that one, and the other side goes to this one. Okay, so that's connected up. There is my choke. Okay, so again, we can double check. We should have a connection now from power in to one side of the bridge rectifier. That's that side, and the other side doesn't. Oh, this one goes through that resistor. This one goes through that resistor. Yeah, 35 ohms. Okay, quite possibly a thermistor. Okay, so we are ready to go. I'm just going to flip the board over. Just make sure nothing shorts against anything. Get all the wires. Yeah, they all look fine. I have just tagged a wire on. This is ground, so I can put a crocodile clip on here, a little lead. I can attach my black multimeter probe, and then I have one and free, which is handy. Okay, so we're going to be looking for the voltages around this 7805, and also on the outputs of these diodes, expecting to find a plus and minus something here. Okay, volts range, you can see the current limiting bulb up there, so we're going to switch this on now, and hopefully the bulb won't do anything. It came on bright, so I'm going to switch it straight back off again. That's interesting. That is interesting. Something went tick then. I think something powered up on here, you know. That's drawing quite a bit more power than I would have expected. But no fuses are blowing, I know that much. Is there any voltage in the large capacitors? I'll just take my multimeter and we'll have to measure directly across these. So what do we have? Nothing. Oh, 9 volts. So this powered up in actual fact. We can say that. There's some voltage in there, so there's not a short. It obviously drew some current. Those are very large capacitors. Could just be the charging current. Especially because remember everything's going through that 30 something ohm resistor. Okay. These are 680 microfarad each. Okay. Nothing shorting against anything. Well, it didn't go bang, that is for sure. I'll switch this on again. Let's watch that bulb again. It's just drawing power. It goes dimmer. Bear in mind that's only a 60 watt bulb. I'm a bit surprised it draws so much power if nothing's attached to it really. Okay. Yeah, 30 odd volts in there now. Same in that one. Okay. Let's try that again with the bulb in and let's check the output of the voltage regulator and these diodes. In fact, let me just go to these diodes. Let's see if I get any voltage here. Okay, do I see anything? Make sure that is the DC end, I think it is. Yeah, the one with the stripe. Let's see. So on here, well, we do have some voltage. Not a lot. Oh, 8. We have 8 volts and it's dying away, yeah, because I switched it off. So output of here, again, let's go. 5 volts. So 5 volts is present. Again, switch her on. So I have 14 volts on that one. 15 volts on that one. So the supplies are there. I thought that would have been a plus and minus. These are discharging again. Okay. This is the EEPROM. It mentioned the resistor in this area could be a fault. I can see one attached to the EEPROM there, so let's check this. Okay, so this 10k, read 10k. That one goes directly to the output of the regulator, so that must be pin 8. So this is actually on pin 4. Yeah, this one is ground, so we have ground and power. So that's pins 5 and 8. Which matches this pin out. So we can see the pin out 5 and 8 of the supply and ground. So pin 1 is the chip select. I'd expect to see some activity on here if the processor tries to read the EEPROM. So let's have a look at that. Okay, I've attached my scope probe. You can see I've just actually attached a lead like this to the BNC connector. So that just goes into the top of my scope. It means I have both hands free basically. Let's have a look to see if we have any activity on the chip select pin. Okay, we know the processor has power, so I'm not too worried about leaving the current limiter in. I could put a higher wattage bulb in this, maybe 100 watt, but I'm not too worried about that at the moment. Let's see what happens on the scope. Okay, I heard something go click. I think that's a relay. There's relays on this. Yeah, you click back off again. So there's definitely power in this. Let's go on again. Yeah, and I don't see any activity on there. I mean, I don't know if I should. is the honest truth. Okay, the relay should go click as the capacitor's discharge. Power's off. Again, we can power up. You see the bulb's actually dimming a bit. I don't see anything happen on the scope. I'm not sure if it would only read the EEPROM once anyway. I didn't see anything occur. I hear the relay going click. So I'm confident enough this thing is powering up. Yeah, relay clicked again, so I'm hearing that again. Something is switching those on and off, which makes me think the processor is active on here. So this is effectively working. Of course, I've not seen one of these before. There's a fair bit of supposition. But that's always going to be the case with this type of repair, unless you see these things a lot. Okay, main capacitors. Yeah, 25, 24s there, discharging nicely. Okay. One other thing I'd just like to check, and that's see what voltage is on those op amps. That I think should have a plus and minus supply. Let's see. Well, it shows a bit negative anyway. If this is what I think it is, there should be a minus supply on here. So we'll just power it up again. Nothing shorting, okay. -9. And I'll just go to the other one and power it up again. Okay. What do we have? Oh, +15. Switch it off again for a bit. Something may be wrong on this negative supply. I would expect that to be -15. Okay, we're on. No, we only have -9 and +15. That seems wrong. Okay, I'll just let it dissipate the voltage. Let's measure the resistance from the negative supply rail to ground and the positive supply rail to ground. Let's see if that tells us anything useful. Okay, so we have to wait till the voltage goes away. It's pretty much gone now. So the positive. A bit. Okay, just let that dissipate away. Let's see if it tells us anything. The other thing I'll try is put the thermal camera on, and let's just see if anything notably is getting what, because this is drawing some power somewhere. Okay, right. Resistance range. It may not read correctly if there's a bit of voltage here. Let's see. So that reads about 500k or something like that, yeah. This one. It reads high, so there's no short there or low resistance. I was just wondering if something was drawing a lot of power and pulling that rail down. I mean, it just doesn't seem right, but bear in mind, I've never worked on one of these before. I just don't quite get it. Let's see if the thermal camera tells us something useful. Okay, I've just taken the macro lens off while I hold this higher up. We're going to power this up again and let's see if anything is getting notably hot. Relay clicked. Tops of the capacitors there, another relay clicked. The LED is on, the red LED, can you see it lit up? No, nothing's actually saying it's hot on here. I don't see anything overheating or anything like that. Okay. So that wasn't conclusive. This way up you clearly heard a couple of relays clicking. That pretty much tells me that thing is running. The red LED is on. That's a good sign. So we have two things. Let's just find the data sheet for that 4560. I know this is a dual op amp. I know this chip. That one. Yeah, see, it's dual op amp. Up to plus and minus 18. Okay, I would expect this to have an equal plus and minus supply. But I can't say for certain, or maybe I can, whether the supply voltage for this chip is referenced to the same ground as the 5 volts. I think we can probably figure that out by poking around. So that's one mystery. Let's see if we can solve this one. So we can see we have 3 windings. One feeds this diode, one feeds this diode, and one feeds this diode. All the other ends of these windings all connecting to ground. I mean, obviously they'll be like a short anyway, but here goes to ground, goes to ground. I think that's the other end of this one. That doesn't. That reads, well, yeah, to ground basically. That also reads to ground. That also reads to ground. And then ground will be on one of these. And that one. Okay, it looks like they're all referenced to ground. So, why do I only have 8 or 9 volts on one and 15 on the other? Why would that be? Well, that goes to there. I've switched the bleeper off at the moment. Resistance across here is high. That's the capacitor. This goes to there. Resistance across here is high. Okay. And this one, I think this is the 5 volts, this one in actual fact. Well, we can soon figure out because of the input to this. Yeah, that's the 5 volts. That's working fine anyway. So, that looks okay. Is there some sort of regulation on this circuit? Normally, you would expect to find a plus and minus 15 volt regulator somewhere. Where is it? Nothing much on this side of the board. It could be discrete transistors, of course. It's a bit hard to say without some reverse engineering. This should be a diode or double diode, diode. They all say D. I'm a bit surprised. I thought some would say Q. Yeah, they all say D, so maybe they're not diodes. Don't see anything obvious on this side either. What's this long thing here? This one. What are you? Toshiba. What are you? TAB 316. Oh, TA8316. Okay, what do you do? Oh, this is the gate driver for that IGBT, so that's nothing we need to really think about. Okay, that's nothing involved with voltage regulation. So I still haven't found out where this plus and minus comes from, but what's this thing? Just marked 2903. Does that have a data sheet? LM2903, okay. Low power dual voltage comparator. So this is another op amp type thing. In the correct pin out. Yeah. This has a single voltage supply. So that isn't the voltage regulator for the plus and minus supply either. I may be able to solve one of the mysteries at least, and that's the low voltage on the minus 15. Because I have my light bulb current limiter in, it's a 65 watt bulb and it's fairly bright, so it's reducing the voltage a lot that's coming to this. It's possible that this supply is more efficient generating the positive than the negative. This is like a flyback type supply, so it may actually generate the correct positive voltages with a lower input voltage than it will the negative. So I could either plug this thing straight into the mains, that's one option, but instead of just plugging this directly into the mains, another option is to use my Deluxe current limiter, this one with 2 light bulbs. This is the one actually built on this channel. I'll link the video to this one. Do my best to remember, guys, I don't always. And we have 2 72 watt bulbs here, so we have a total of 144 watts. That means that they will light up dimmer if this is drawing the same current, so there'll be more voltage getting into this. And then we can check the minus 15 volts again and see if it comes up correctly this time, okay? So we go to volts on here. This is set to limit. The bulbs, you either use both or you just unscrew one. There isn't a switch to actually switch the other bulb in, but that's fair enough as it is. So let's power this up again and let's see what it does now. Well, it's much dimmer now, so we can see that there's much more voltage getting into this thing. Okay, it's drawing more power. Let's have a look at the negative voltage supply now. There's a relay on click. And we still have minus 9. Okay, I'm going to switch the limiter out, so we're directly on mains. What do we have? We still have minus 9. So, that is still a mystery. Why? Then we have 2 things to investigate here. One is, should it be plus and minus 15? I'm guessing they should be the same. And secondly is, there a problem with the firmware? Maybe that is a red herring, so we need to figure out also how to find some firmware for this. I admit I don't know where to find that. Maybe some of you guys do. You have the model numbers you've seen on this video. Otherwise, I have to research that a little bit further. And of course, figure out if my EEPROM programmer could even program that chip. Or do I need another one? So guys, from knowing absolutely nothing, we now know more or less nothing, okay, about this. One thing very suspicious is that minus 8.9 volt supply. I just don't know where it's coming from. So there will be a continuation of this, I'm sure. The question is, where does that come from? Is it correct? Is it not correct? I don't know the answer to that question, but I do know it looks strange. And I hope some of you agree with me on that one, okay? Number 2, can we find a schematic for this thing? I haven't even looked, but you know, we could get lucky. There are some numbers down there. Yeah. Can we find a schematic for this? What is it? K08CU thing or K0BCU? Oh, same number above. K08CU-02-01. Could we find a schematic? And the third one is, if we take the information online that this is an EEPROM fault, then can I program that EEPROM in my EEPROM programmer? And if I can I get the firmware for this? Yeah. And where would I find it? So I'll go away and have a think for a while. Yeah, that's about as far as I can get in this session. Maybe at 4 AM I'll have some good ideas. Maybe you guys will have some good ideas as well. So, okay, let's get this one published. Yeah, it's done. You're watching it. Let me know what you think about it, and I'll have a good think myself to see how I'd like to proceed further. Okay, hope you enjoyed it. Look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.